Hello, Calc PC. So this is a short video that's going to kind of set us up for the main lesson for the day. Okay, so the first thing I want to do is talk about what a sine line graph is. So a sine line graph is a picture of where a function is positive or negative. And usually this is going to be represented in one dimension just along a graph. So just you have like a line here, we have positive on the right, negative on the left, and and we have like positives and negatives above it in different regions. So we split it up into different regions to mark where is a function positive versus where is a function negative. Okay, so suppose I tell you first off you have f of x equals x squared minus 4. And we want to draw a sine line graph for this. So what we do is we first off just start by graphing this. So what we're going to do is we're going to split this graph up when your function is 0 or undefined. So you say, okay, well, this isn't undefined anywhere, but this is equal to 0 when x squared minus 4 equals 0. So we can factor that out, or I guess solve by square roots or whatever. So we split it up when the function is 0 or undefined. Okay, so we split it up at 2 and at negative 2 because those are my solutions. Okay, so then what I'm going to do, so that was my first step to split it up. Now, I have split my graph into 3 different intervals, there, there, and there. So what I'm going to do is within each interval, I'm just going to pick any point. Pick a point, and then I'm going to plug it in f just to see if it's positive or negative. Okay. The actual value we get doesn't matter, so I'm just going to pick a point. So anywhere from 2 on to infinity. So I'm going to pick, I don't know, x equals 4. And usually, I can just plug in here. Usually I plug into a factored form, but in this case it doesn't matter. So f of 4 equals 16 minus 4, which is 12. Now it doesn't matter what the number is. What matters is that it's positive. Okay, so now we pick a point between negative 2 and 2. Now the obvious one is 0, right? If you can ever pick 0 to plug it in, you should pick 0. So f is 0 minus 4, which is negative 4. So we'll put in a negative there. And then we'll plug into, I don't know, x equals negative 3. So your f there is 9 minus 4. That's also positive. So this is our answer. This is a sine line graph of your f of x. And we want to label it with your f or whatever. And this shows you where the function's positive, where it's negative. So it's saying everywhere bigger than 2, f is positive. Anywhere between negative 2 and 2, it's negative. Anywhere smaller than negative 2, it's positive. And the reason you split it up where it's 0 is because that's where it's switching signs, right? That's where it goes from positive to negative, or vice versa. Okay, so let's do another example. Here, I'm going to give you a second derivative. So g double prime equals x squared minus 8x plus 16 divided by x plus 2. And I'm going to try and draw a sine line graph of g double prime. So I always want to label something like this. So g double prime, again, I'm going to do that. Okay, so I'm going to split this up when your g double prime equals 0 or when your g double prime is undefined. So in this case, we're undefined when the bottom equals 0, so when x plus 2 equals 0, so when x equals negative 2. So when we're undefined, that's where we can see a sign change. When the second derivative equals 0, that's when the top equals 0. So that's when x squared minus 8x plus 16 equals 0. So you can actually factor this as x minus 4 squared. So the other critical point is that x equals 4. Okay, so now let's plug in. And one tip I wanted to give you, I kind of factor this out down below, but usually when you plug in, it's a lot easier to plug into that factored form. So plug these points in to factored form. Okay, so maybe, let's see, smaller than negative 2. So let's plug in x equals negative 3. So when I plug those into the factored form here, negative 3 minus 4, so I have something squared, so I have a positive over negative 1, so that's a negative. When I plug in 0, I get negative 4 squared divided by 2, so that's positive. When I plug in something bigger than 4, say I plug in 10, I have 6 squared over, it doesn't matter, it's positive. Okay, so there's our graph. This is our sine line graph that shows us where that second derivative equation is positive and where it's negative. So we split it up, and then we went ahead and we plugged in points. So that's sine line graphs. Okay, the next thing I wanted to do was talk about something seemingly unrelated called a critical point. You're going to see some relationships here, but we're going to say this. So this actually has to do with a derivative. So a function f has a critical point where f prime is 0 or undefined. And you might be saying, gee, where something is 0 or undefined, that's where you split up a sine line graph, and that would be an interesting thing to say. Okay, so for example, let's say I tell you we have just a straightforward function. F is 3x cubed minus 9x minus 4. And I'm just going to say find all the x values where f has a critical point. Okay, so all we do here is we see basically like where is f prime. So we actually have to take a derivative equal to 0, and where is f prime undefined. So obviously my first step in finding critical points is I need to go ahead and take a derivative. So I have 9x squared minus 9. Well, that's not undefined anywhere, and I can factor out. And we see in this case, my critical points would be at x minus 1, x plus 1. So my critical points are x equals 1 and negative 1. Okay, cool. So the next thing we could see, I could give you a slightly more example. So what if I give you the derivative already? So I say find critical points or crit points of g, given that they give you the first derivative is 3x plus 2 over x minus 1. Okay, so again, we check to see where does g prime equal 0, where does my g prime undefined. So it's undefined when x minus 1 is 0, so at x equals 1. The first derivative is 0 when the top equals 0, so that's x equals negative 2/3. So those are your critical points, right? They already gave you the derivative, so we didn't have to find a derivative, right? The g prime was given here. Okay, so that's how we find critical points, and then the top, we talked about how to draw sine line graphs of a function, and this is going to be a great setup for the next video. Thanks for watching, guys.